All right. And we're live on Energy Superheroes. Today we have Kevin O'Donovan, and Kevin is a technology evangelist. He knows energy and digitization better than really anyone we know. And today we're going to talk about digital twins. Kevin has a background with Compaq, HP, and Intel. So he is eminently qualified to tell us why digital twins are important. We're seeing it more and more. And so we're excited to learn more. Kevin, welcome to the podcast.
Peter, hey, great to be back chatting with you. It's been a couple of months. Time is flying. And
Couple of months. Yeah, it's a couple of years, right?
it's like the pace of technology these days. It just seems to be, time seems to be going by faster, or maybe it's just me.
Faster.
Yeah. So, you know, we've been talking about digitalization and the impact of technology on the energy industry, for decades, right? And to be honest, it's a never ending cycle because whether it's ChatGPT or AI, there's a new thing and whatever. But I do think we're kind of getting to an inflection point is probably too hard a word, but we're getting to a stage where what we now call a digital twin is opening up all sorts of new capabilities and possibilities that we really didn't have in the past, not at the scale. And I suppose my logic would be the following. So I was off at CERAWeek over on your side, a couple of months ago now, Distribute Tech. We had Hanover Messe here in Europe. So everything around industrial energy, automation, do things better, more sustainably. It was all about de-risking things. And what I mean by that was that we need to design things better. We need to game things out before we build them much better, whether it's wind farms or whether it's carbon capture and store, whatever, right? We need to plan it all out. We need to game it out all out on computer modeling, if you like. And then once we start building it, we start getting in the real-time data and whatever. So honestly, think we're changing. Now, people will probably say, but we've had digital twins for years and IoT is not new. So what's new, right? That's a valid question from everybody. You're probably seeing it as well, but I have a particular point of view on that.
So what you got to tell me is digital twins, why has the time come now? And I understand the risk standpoint, but has the technology advanced to the point where we can actually design a plant just as good as the mechanical engineers could in the past? Are we there yet?
We aren't there yet. And many people that are off today designing buildings and factories and oil and gas and whatever, they already do virtual commissioning, right? That is their job description. And by virtual commissioning is we design everything in a 3D CAD package, which we've been doing for years, right? And the financial sign-off comes from that design, right? Now, what's different is, and to your point, right, we've been talking about digital twins for years, and its most simple explanation, we say a digital twin is a digital representation of a physical asset that exists or we're going to create. And to be quite honest, that covers everything, right? That's soup to nuts. And what I mean by that is that if you have a CAD design, which we've had for 10, 20 years on AutoCAD or SolidWorks or CATIA or, pick a 3D design tool, you could say, well, that's a digital twin, but this is what we're going to build. It's the architectural plan. We've been talking about, okay, well, now we have stuff that we built 20 years ago. We need to send drones around, get LiDAR scans and whatever, and that creates a point cloud. That's a digital twin. We've been rolling out industrial IoT solutions in the grid, in factories, oil and gas, whatever, for the last 20 years. Some of them are better than others. Some of them are more real time. Some of them are we get data once a week, and some of them are we get data like a SCADA system, we get data every millisecond. And you could say, well, that's a digital representation. So they're digital twins. But my thought and what we see in the industry is that they are digital twins, but they were siloed. So they were with one thing. So when you had the CAD design, and people have been looking at, okay, well, this is what we were supposed to build. We're now doing drone scans as we build it to kind of map up to go, are we building what we said we build, or is it changed? And, there's always changes or something, the pipe length is different, whatever, right? So we're going to see that map back. And then you start plugging in the real-time information from the IoT systems. And again, some people are doing that already. If you look at any of the usual suspects in our industry, so whether it's ABB, Siemens, Schneider Electric with Aviva, GE, Yokogawa, pick a technology provider. They all have a suite of digital twins and plans and whatever. But what we're seeing is we're starting to see these things become more immersive. So it's not a 2D model on a 2D screen. It's a 3D model. You're all looking at it on a 2D screen, but you can kind of move around. It's like a game, but you can walk around and you can get a perception, spatial perception of what they're building and see things and whatever. So it allows for better collaboration. But the key thing that's going on, and we're seeing more and more of this, is that, okay, so you have a digital representation of what you're going to build or what you have built. You have some real time data. Now I want to do a physics based simulation on what if happens. What if I increase production by 10%? Not just on that pump, but on the platform. And it's a simulator. And if you look at, again, the usual suspects, Siemens, Schneider, whatever, they've all had physics models for calculating the flow and the turbulence and fluids and liquids and whatever for years. And that's what they do. You have people designing the electrical systems and flows of electricity and that. But now you start building in more and more physics models from, believe it or not, the likes of the game engines. So you have the likes of Epic, guys who write Fortnite, you have Unity Industrial, and you have NVIDIA with NVIDIA Omniverse and others. And what they're all doing is taking data from all the other existing digital twins and starting to munge it together. Because I have seen a demo where someone's going, we're going to build a offshore wind farm. Right. Models come from whoever builds the wind farm, the turbine. We start putting those out. We start doing all the mooring lines and whatever. Again, you'd say, well, that's just the design. It's whatever. But then you start simulating the ocean currents because all those physics models exist. And you start going, well, this is how it'll work. And the wind comes from this direction. So the whole concept of what's going to be blocking, which wind turbine is going to be blocking the other guy, all the layout, that's all being done today. But then you start going, okay, well, what happens if this mooring line breaks with this wind, with that tide? And it's like a computer game. It starts, this is what's going to happen. It's going to crash into this one. So how would I stop that? So the thing with simulation that to me is completely different is you can game out all of these scenarios in minutes, hours, whatever, in a way that we couldn't do with pen and paper before. And throw in a bit of AI and you start, all sorts. And what does that do? It de-risks the project. And if you look at the energy transition, the name of the game is we need to deploy more stuff and more of the stuff we know how it works faster. So we get permitting faster. So we get more sustainability. So when people come back and say, well, what if this and what does it look like? And even with consumer engagement, I don't know what that wind farm or that new hydrogen plant or that new transmission line is going to look like in my area. Well, here's a photorealistic. This is what it's going to look like. Now, they may still not like the project, but that time to make a decision on what people think about it, what they need to change, that's just accelerating. So I honestly believe that specifically when it comes to building new infrastructure, I look at what's going on with the Inflation Reduction Act in the US, the EU Repower and how it changed to compete with the IRA. Everything's about we need to go faster. We need new gigafactories for batteries. We need new hydrogen. We need new CS. And we need to get to digging a hole in the ground, signing off faster. And I honestly believe this is where this digital twin technology starts to enable that de-risking and faster time to make an informed decision. I think it's at a level we've never done before. So whether it's next generation digital twin, we want to call it, or the ability to do the simulation, to me, this is different. And there's companies out there today doing it. And I'll give you a few examples in a minute, right?
No, I definitely want to dive into that more. And you hit a magic word for me as an investment banker, which is de-risking. And I can tell you every deal that we take to market, entrepreneurs are always thinking, how can I make the return higher? But it's not. It's about how can I de-risk this project? Because the returns are there. It's a new industry. There's huge opportunities and upsides. But what investors care about is fiduciary duty to their limited partners. It's all about de-risking. And so I could not agree more. And I also agree that, oh my gosh, where's the problem with all these projects? It's in this scenario piece. Well, it's financial modeling. And then also, we do see a lot of inexperienced developers that are in the market that I'll say are getting taken advantage of by their EPCs, right? And so I look at it as there's a pot of gold here and there's a pie and everybody wants to split it. But if the construction companies are taking 90% of the pie, none of this stuff's going to get. And so I think the way that you keep any sort of contractor honest is by having clear work scope. And so to me, that's what this does is it creates clear work scope and scenario modeling so that the investors can get behind it and know that their returns are going to be stable as opposed to being, let's say, taken away by a third party.
The other thing I find fascinating with some of the projects I've been involved in, both in energy and industry in the past 12, 18 months, when you start breaking down those silos, and not necessarily just in one big company, and God knows there's a lot of big companies with a lot of silos, and that's hard, right? Getting all that stuff and the transparency, whatever. But even across supply chains, and to your point, if you're building any kind of infrastructure today, it's like, well, where's the raw material comes from? Then what happens when something like the war in Ukraine breaks out and my supply chains go pear shaped? And now I have a different carbon footprint for the steel I'm using and its brittleness and whatever. So you can feed all that into the design model. And like how do they test for brittleness and how many times can I turn this thing on and off in the next 50 years? Most of that's done in computer simulation today with physics-based modeling, right? So that's all happening. So you can start feeding that in. But I'll tell you, and it's a bit of a double-edged sword. What's fascinating is that if you start kind of looking at something like what NVIDIA Omniverse and others are doing, where, hey, look, we'll pull data from this company and that company and this, and we munge it all together, and you start getting that next generation digital twin, whatever, the industrial metaverse, whatever you want to call it, industry 4.99, something. What happens is that you are exposing data from various parts of the company, and other people are looking at your data and they're going, some of your data looks a bit weird or odd, or, a utility company. What percentage of your smart meter data is actually right? Because there's a few outliers, right? And that's a whole can of worms. Now, the good news is that, to your point, there's a lot of transparency, and that can be used for good because you can start seeing, well, who's doing what and are there any roadblocks, and again, game out what happens if this happens and that. And, it's down to the thing of, on construction sites, Bentley Systems and others today will do the entire, okay, we're building a new, whatever, oil refinery or a city or whatever. They game out when, well, to build this, we need a crane to come in and park this here and lift that, and it'll take 1 day or whatever. We need the concrete trucks to arrive at the same, whatever time to start pouring concrete. And then they start, again, like a game engine, they start planning out, well, the timing. They call it in 4 dimensions, right? Because it changes. Because we've all had experiences with companies we know or whatever, and they'll say, oh, God, last week was a mess. We were a week late and the crane was there and the cement truck turned up and it couldn't get to where it was going to pour the thing. So we had to send it away, and another week gone. This kind of stuff. So you think digital twin? Well, it's a digital twin of traffic management. And you can game it out. Well, what happens if this guy is a day late? Oh, God, the wheels will come off. We can't move this thing from here to there because that's going to be in the way and whatever. Now, today we've done that with people, knowledge that was built up for years. And you have project managers and scheduling coordinators on these massive projects. And they are incredible people because they've been doing this for years and they can spot it before anyone else does, right? That's their job. But imagine how a digital twin of your construction site, and again, to de-risking, how can you guarantee me you're going to be on time? Well, we're using all these new techniques and knowledge and computers and law to make sure we don't end up with some snafu where, oh God, we're 2 weeks off schedule because the crane was late or something, right? Does that make sense?
No, it absolutely does make sense. And I'll say, not only is it a difference between a project being profitable or not profitable, in a lot of cases, does it get built or not? Because if you're in your engineering phase and your engineering before you can even go to construction costs $100 million and takes 2 years to do, then that project is most likely not going to be built by a third party developer. It's going to be built by somebody with a balance sheet. And that significantly limits the amount of projects that can be built. And if the goal is to get to net zero by such and such a date, if it's only a small number of companies with a low cost of capital and balance sheets that are going to be able to build any projects, we're not going to meet our deadlines, period. We've got to have lots of developers getting involved. But if the cost of the engineering and the time it takes to get to market is too long, I think we're finished. So I actually think this technology might be the difference between total success and total failure for the energy transition. It's physical stuff we're talking about here that has to happen. It's not building an app. It's not that we can just beta test it until it gets worked out by the users. Doesn't work that way. And so we have to bring this digitization capability into the physical world. Otherwise, I don't see how we meet energy transition target dates.
Now, you know, as we've chatted before, we talk about digitalization for years and whatever. And let's face it, if you're building something new, so a greenfield site, it's always easier to build it with the latest and greatest than retrofit some brownfield thing, right? And that's hard, right? And then how do I put sensor? But an example of where I see the kind of the digital twin and the energy transitions, the match made in heaven, is things like gigafactories that are being built you know, from nothing, right? There's whatever. So new technologies, new robots, new whatever. So you'll have seen announcements at Hanover Messe from Siemens and Giga Arctic and NVIDIA and with AWS on how they're doing all of it. Before they dig a hole in the ground to build that factory, they were designing everything in a digital twin. But like they were also designing it in terms of, well, how do we design the batteries? And then how do we design the robots to make the batteries? But how do we do it in a way that we can recycle them easier later? So what kind of a machine would we need to recycle? And again, it's simulation, right? And it's all done in one big tool in the sky. So imagine just again from a financial point of view. So if you can go to them, look, we gamed out 10,000 scenarios with this thing and whatever, and we figured out that if we build them this way, might add 5% of the cost, and it whatever. So transparent law. We do this, but when we go to recycle them, we can rip them apart in 5 hours instead of 100 hours. I'm just making those numbers up, right? But you know what I mean, right? So you can start gaming things out. And again, back to now, the investor might still not go, yeah, but you can kind of start proving to him that it's not just an idea that's not proven. The other thing with CCS, right? Let's face it, we've had CCS for years and what do you call it, enhanced oil recovery and whatever. But a lot of this CCS technology is relatively unproven. And, in the old days, it was like, well, Sir Peter, I want to sell you this. And you say, great, like the idea. Show me all your reference cases and the people who've been doing it for the last 20 years and say you're a good guy. And it's like, well, no one's ever built this stuff before. So you've that chicken and an egg. But now look at what Oxy are doing. Look at, pick a chemical company, pick anybody, right? They're all going, we're not going to stop doing what we're doing, but we got to reduce our emissions. So CS has to be part of it. So instead of let's build a prototype for us, you say 100 million, and then we'll kind of figure out what thing. Again, it's all being simulated. There's a company out of the UK, Pace CS, partnership with AB, entire ecosystem of carbon capture and storage in a digital twin before anybody starts building it. And the physics models down to the flow of gas, the corrosiveness, the type of, at an incredible engineering level. But that's where we're going. Not, people think of it, it's just an animation. No, it's simulation. Physics-based simulation based on the real world in oil and gas. Laws of physics haven't changed.
It's an absolute game changer. I got my start in the energy industry with a company called PowerPhase, made an upgrade system for gas turbine plants. Okay. And it was a dry air injection system. And what happened is it took us about 5 years just to get the first person to say, yeah, we'll install one of those. Well, why was that? Because we had this great technology, but show me one that's running. Show me one that's been running for 10 years. Right. So
De-risk.
it's a chicken or an egg problem. And I would say that's maybe the number one reason why venture capitalists are not funding more hardware deals, why they gravitate towards software, because it takes so long for hardware to get deployed in the field and proven. And so ultimately it stops you from having unicorns in the energy hardware world because they're going to have to sell to an OEM for say 100 million or 75 million. They're never going to get that $1 billion valuation because they can't do it on their own. Well, this could potentially solve that because you're now able to prove maybe even better than a live environment because you could run it in 100 environments and show exactly how it's going to behave. And so, yeah, I think for hardware deployment, new tech, it's a game changer. For projects, it's a game changer. I think it's really like the linchpin of speed in the energy transition.
A couple of examples that I've seen at various projects and whatever would be, okay, so the engineers have gone off and they've designed you have the building and you have the piping and the whatever. And then there's multiple reviews with financiers or whoever's the signing off on the check, right? Going next phase. And there's multiple Zoom calls and they're all looking at 2D printouts or whatever, right? And it's like, yeah, I'm trying to visualize what it looks like, whatever. So now you have like a game engine, and on my keyboard using my mouse, I can kind of walk around inside it. And if I'm looking at, I don't know, whatever, the generator or some part of it, and I'm kind of going, I don't understand. What's that? Whatever. I can walk around it in the thing and go, okay, no, I had that question. No, I don't have that question anymore. Or you put my mind to ease, right? Or I can ask a nastier question, but I'm looking at real data. And we're all looking at the same model. So the collaboration capabilities. Now that's long before I know people who are then, it's a 3D model. It's all built on standards. And then I can now import that into a VR headset. So I can put on the VR headset and I can walk around and I think I'm in the thing. Now, that's not for everybody, but I know some companies are doing it, and that's how they're collaborating and whatever. And we see Microsoft with the industrial metaverse and blah, blah, blah.
We're definitely going there. I can support you on that one. I actually had somebody ship me a VR headset recently, gave it to me for free just so I could explore their software. And it was amazing. Like you get in there and you can actually see a facility. You can look at whatever the equipment is. You can open up and even look at the engine and how it's running. And we're definitely going there because they say, one of the things they say is nobody ever got fired for going with the OEM, right? Lots of people got fired for going against their engineers. And to your point, if the engineers can't scratch that itch and be able to approve it, it's not going to move forward. This is another thing that stops projects from going. And so they have to be able to put their hands on it, put their eyes on it, and feel like it's real. And there's no other way to do it other than A, you build a prototype for hundreds of millions of dollars, or B, exactly what you're saying, you go to virtual reality. I think we're headed there.
And look, virtual reality, whatever. I'm big into the whatever. I host meetings and engage and blah, blah, blah. So all in. But it's not for everybody, right? And it's not for every use case. But for a particular, let's have a walk around just to get, so you can visualize what this offshore terminal, the new LNG thing we're building is going to look like, just to give you an idea. And you're there, you're more immersed. And it's not just a nice marketing video, right? What you're looking at is the actual engineering plan, not the marketing departments, what it might look like. The engineers that are whatever, and the engineer that's designing it is there with you saying, that's why we did that and this, that, and the other. And you're like, okay, it's much more thing. Now, just to where the art of the possible. And this is where we're headed. BMW announced at Hannover Messe their new electric vehicle factory they're building that's opening in 2025 will be completely designed and tested, and they will do all the user training for the operators and the employees and whatever at the end of 2024 in a digital twin.
Wow.
Right? Before they start, before the building, thing won't even start for another 12 months to open. NVIDIA talk about the photorealistic factory. What themselves and Siemens and many other partners and whatever are up to is that we'll have lots of robots running around in these things. We see Animal out of Switzerland. We have Spot walking around whatever oil and gas platforms and whatever. Those robots are basically pieces of software. Some of them are AI and whatever, right? So you can run this, you can run the software for that robot. It's getting data from the sensors. The sensors are being spoofed because they're in a digital twin, but what they're seeing is photorealistic things of the factory floor and whatever. So I can do all sorts of things. And like autonomous driving, that's where they're going, is that I can simulate people of different skin color walking across the street in different lighting conditions, rain, snow, whatever. And it is photorealistic because look at the gaming engines today. And I can do all of those iterations and testing and will the braking system work? Can I get the robot to run around the factory without running people's legs? So the permutations, the combinations, again, the simulation, the amount of them I can do to be able to go back to you and say, look, is this perfect? Probably not, but we've done this and we could never do this in the real world. Now, again, this is the art of the possible, and we've a long way to go to get to that. But you just see what's going on. You go to CERAWeek, you see what people are presenting today in terms of we're designing the new CCS plant for Oxy, and it's all on a 3D model. And then they're designing it that it's not a silo. It'll be, then we plug in the data, and in real time, in 3 years' time when it's built, we'll be able to go, if we increase production by 5%, what will happen? And what I mean by what will happen is that we have real-time data saying that there's 100 pumps in the facility. 2 of them are a bit out of whack. So we flagged them for preventive maintenance. But based on machine learning, the models we have today, if I increase by 5%, is there any chance one of them will go? And in real time. So the
That's
production facility guy is going, guys, we can't, if we turn this on, we could be out for a month, right? So you can imagine so in some ways you're saying you're narrowing operational criteria because you're based on real time. That's money. Now, this is not easy. This is not without risk. The more we digitize everything, the more cybersecurity, you know, that's not gone away. So this is not nirvana, but I honestly do believe that where we're headed, and when you see the likes of all the usual suspects investing in this, you see lots of startups adding in bits. You take all of the money and the urgency that's been driven by the Inflation Reduction Act, Repower EU. We got to build this stuff faster. We're building new stuff in many cases. So how do we de-risk that? Simulate, simulate, and simulate. Now,
right.
you can obviously go, I don't like your model and I think we should this and whatever, but at least you have something it's not just a wing and a prayer, right?
I know for sure. And again, I hate to keep just agreeing with you, but I couldn't agree
You
more.
don't think I'm mad?
I wanted to challenge you on this, but I think it's going to be faster than everybody anticipate. And here's where I think the AI comes in. And I'm very much an AI optimist because I think human beings have this creative spark, this ability to take something from nothing and make something that nobody would have ever thought of. And I don't think that's going to change. Where the AI comes in is you could say, okay, I thought of this amazing plant or this amazing piece of hardware. And you can ask the AI, it's safe. And now it's going to run thousands and thousands of simulations. So rather than have to sit there and be, call it Mr. Bureaucrat and write down every single possible thing that could ever go wrong forever and run all these scenarios, 100 versions of the financial model and 1,000 versions of the engineering drawing, you let the AI come up with it. Now, is it going to get everything? But it's going to get a lot of them. And what that's going to do is free up creative people to really take their game to the next level because they're not going to get stuck in the weeds of having to go through all these iterations. And so to me, I'm a super AI optimist as well as digitization optimist. I think this is the game changer. I think it's the difference between, like I said, success and failure when it comes to getting to net zero.
To me, I talk a lot about the industrial metaverse and people say, oh, the metaverse is dead and whatever, right? And it's, yeah, yeah. And, I don't care what we call it, to be honest. It could be industry 4.0 is the digitalization of industry. So is it 4.99 or whatever? But digitalization is not slowing down, whether it's the communications, we've now got private 5G and energy facilities being rolled out, more IoT, more AI, more software, more models, more immersive collaboration requirements because the team that you're working with could be God knows where. And the usual way was we'd all come into a big room with a big printout engineering drawing. We all start scribbling on it. Now, granted that some people still do that, most don't, but you can just imagine the VR collaboration, whatever. So this is where we're headed. So to me, whether it's just the next phase of digitalization on steroids, it's happening. Now, whatever we call it, but in terms of de-risking and getting stuff faster, it opens up all sorts of possibilities. Now, that does not mean it's without risk. It does not mean it's easy. And it doesn't mean that human nature has changed because a lot of this is change. And, I think change is a great thing. As long as you change, I'm fine. All right. We've all
Absolutely.
seen that, right? So that's not changing. So, and I am also optimistic on AI. I think it will change a lot of the things we do, but I think mostly for the better. The AIs today are incredible, but they're good at talking. They're not good at thinking.
That's absolutely right. I couldn't agree more. So, well, let's shift focus a little bit. I would love to get your thoughts on number one, any companies that you know that are out there. Let's start with maybe some big companies that are doing a great job in digitization, digital twins, and all this stuff we've been talking about. And then, do you know any startups that you can reference that are doing a good job?
It could be a long list, but it depends on how you're doing, how you define good. Financially good or
For me,
technology
good.
good.
And the finance guy in me wants to say financially good, but for the purposes of this, I'm just excited to know is who's pushing the envelope, who's doing Really cool.
So for transparency, people that know me, I do a good bit of stuff with Siemens and what they've been doing around industrial automation. They've been talking about physical meets digital for years, and now the industrial metaverse and whatever. They partnered with NVIDIA, they partnered with Bentley Systems, whatever. So they're one in the industry and energy side, and you see what they're doing with their grid software and simulating, and again, when you think digital twin, okay, if 100 more people plug in an electric vehicle at the end of these feeder lines, what happens? Which substation goes poof because I can't supply them all, right? Or where do I need to put batteries in? So again, digital twin, iteration after iteration. What happens if temperature drops and everything? So just scenario planning. So that's all happening. Schneider Electric, they closed the acquisition of Aviva, huge digital twin portfolio. ABB, Pace US. To be honest, it's like anything you say, who's got a digital twin? Everybody's got a digital twin. And then when you start digging into the weeds, what do they do? Do they have design tools? What do they integrate with? The other thing, one thing I would say to watch for is things like NVIDIA are pushing USD, Universal Scene Descriptor. It came from Pixar, but it is a way of describing an object, a 3D object, so that if you move that object into other software platforms, it looks and it behaves the same. Because even if the color changes, the texture changes, and you're doing simulations in a photorealistic thing, well, the last thing you want is different answers. So all the standards have been done. So in terms of the big guys, and then in terms of the big energy companies, to be honest, there's not many utilities on the planet today that are not going, we have to plan the whole electrification that's going on without our knowledge. People are just buying electric vehicles, and you see all the incentives in Europe and in the States and whatever, right? That bus has left, right? So they have to start planning so that the end customer, if you like, they're all what if scenario, and this is for digital twins and the scenario planning. And they've been doing this for years, but not at the pace and the what if scenarios. You look at all the oil and gas, mate. You go to the Gulf, you look at ADNOC, you look at Saudi Aramco, you look at Oxy, you look at Shell, pick a one, right? They're all going carbon capture, hydrogen. We need better LNG facilities, whatever. All that stuff that's being designed, all digital twins. No, there's no one doing that in pen and paper anymore. And they haven't been for years, right? So this is the thing, is that people in the industry will say, Kev, this stuff, we've been doing this for years. You have. A lot of people would say, I didn't know you did that. Knowledge is relative. But where I think it's headed is the big guys are starting to work better together and standards. And you have the new gaming engine guys coming in. Unity Industry, NVIDIA Omniverse. That's a whole, now you what's that gaming engine doing in this world? The physics models and what's fascinating. In terms of startups, if you look at what Dassault Systems are doing with their incubation programs, all on cloud. Because again, all of this is based on cloud. Now you might say security and cyber and whatever, but NVIDIA Omniverse is on cloud. Bentley's iTwin is on cloud. What does that do? That allows a much lower barrier to entry. If I'm a startup, I don't need massive software license. It's like I want to play with SAP. It costs you $1 million for the license, right? Now they've changed their models as well. But now it's like Salesforce thing. I just want a small license and I just want to play with stuff. And I want to create digital twins. And I want to be able to go, I think I have an opportunity here because I was made all these digital twins of generators and grids and wind turbines and whatever. And I could sell it to my town by going to the town commissioner and saying, okay, come here, if we start doing, this is what it look like. And this is what that charger looks like versus that. And if that one's bigger, that'll block this and whatever. So there's lots of, I work with a lot of different startups in different industries. Some of them are very innovative. Like some of them are all going, it's all in VR. And I go, cool. I don't think we're all going to be living in Ready Player One next year, right? It's not going to happen. I hope it doesn't. But VR, I've seen a bunch of companies doing, hey, we have a repetitive work in a factory. So a person puts on a VR headset, they're in the thing, and you can watch them working. You can put sensors on their body or just stand behind them and watch them work. You'll see that they're leaning in a funny way to reach a certain thing. That's going to be a repetitive injury. So what I can do is that desk needs to be 6 inches, 10 centimeters closer to them. So that'll stop the weird twist in their back. But if I move that, what about that robot arm? Does that need to move? So all of this iterations and stuff. And it's not that I'm not pointing out any, invest in this company. I don't do that, right? But to cut a long story short, I think we're just seeing You mentioned it earlier, the innovativeness of humans. This isn't all the AIs doing it, but the more people that'll kind of get access to these tools. And like we talk about the skills we'll need for this, look at all the kids and teenagers and old teenagers like me that are off playing Fortnite and Roblox and Minecraft and World of Warcraft and all these kind of things. And they're not just for folks that have never been into these things. It's not just about playing the game, which is one thing, but all of these gaming platforms allow you to create your own game. So I invite my friends to come look at the island I built and we'd run around in here and shoot each other. And what are they learning? It's kind of low code, no code type stuff, but you can spatial 3D models, physics models, those skills that they're learning. And, people say, oh, Epic, the guys who built Fortnite, they have Twin Motion, a digital twin viewer for industry, right? Unity launched Unity Industry. So as I say, I think the wheels are just starting to turn on this one, but it's not the answer to we're done. It's going to be hard, but I find it fascinating.
And no, like anything worth doing, it's going to take a long time. And I'll give a plug to my son who's in college at University of Central Florida, and he's going to get a master's degree from the number one rated program called FIA, Florida Interactive Entertainment Academy. So he's in that digital space. And I keep telling him, and I say, son, you got to take a look at my industry because I think there's going to be a lot of opportunity there. He's extremely creative. So he's building these games in virtual worlds, just standard games. And we play games like GTA together. Nobody judge me, but love the game. And but I keep saying the convergence of energy and digital technology is going to be amazing. And this is our moonshot of this generation is getting to net zero. It's going to remake the entire physical world in the same way that the last internet revolution remade the digital world. We're going to have this crossover now between digital and the physical. And it's going to be incredible. You see it with already in the US campaign, candidates talking about building from scratch new cities. And how are those going to be designed? It's going to be in these engines.
I agreed. And people say, Kev, you're smoking something and whatever. What else would you say? You're a geek, right? I am. But to cut a long story short, like back to your point, that this is our moonshot as a generation, right? We have an opportunity to change things. It's not that we have to change everything overnight, but we need to get better in CCS, hydrogen and batteries and this, that, and the other. And we will always have people, rightly so, going, hang on a second, we've never done this before at this scale. So the risk must be huge. This is where that simulation piece and helping de-risk some of that by going, well, we've planned out all this. Is it perfect? No, but it's a hell of a lot better than if we were doing this 10 years ago.
No doubt.
So that's got to be a positive, right? Anyway.
Well, Kevin, we're at time here. I know you got a hard stop coming up. So, man, the time went by fast. Before you go, can you just tell the audience how to get in touch with you? And is there any website or book or anything that you'd like people to check out?
The easiest way to find me is through the notes on this or whatever, the LinkedIn, Kevin O'Donovan on LinkedIn. What I do, and I'm a technology evangelist, so I go off and spread the good news about new technologies in collaboration with a lot of different companies and at events, and I get to meet a lot of interesting people. But I advise, it's startups, large corporations going, well, what are the implications of the energy transition and digital twins? What's the implications of whatever? Kind of gaming out stuff and that outside in perspective in terms of, we've all been in our own companies and we're working really hard and we're going, we have a great plan. An outside person coming in kind of asking all the why can be quite annoying, but can be quite insightful for them. So that's the kind of the stuff I do. So easiest way is on LinkedIn. I have a website. I'm a fractional executive with 121. So I get up to various things, but the last time we chatted, we say, hey, it's getting faster. It is getting faster. And we have to, as you said, it's our moonshot. And so if you think it was going fast now, buckle up. We're just getting going.
Very good. Thank you, Kevin. This has been Kevin O'Donovan, and make sure you check him out on LinkedIn. You can find us, look up Energy Superheroes on Spotify. We're also on YouTube, and I'm Peter Perry on LinkedIn. Everybody, thanks for joining. Signing off for now.